be solved, right? And this is okay when you're building interactive tactics, but a lot of people want to build non-interactive tactics that are useful for building bigger tactics, that are useful for building bigger tactics, right? Until you make them interactive, right? For instance, one example is basic building blocks like intro, revert, and apply. They're extremely useful, right? For instance, I will show later in my Emacs that intro and revert are used to implement substs, right? That we all use in interactive modes. There is this idiom type theory, right? Where you have to revert a lot of stuff, do something, and introduce back because of the dependencies in dependency type theory. And we often use intro and revert before we do something more complicated. Apply also super useful when you are building some term, right, in a more complex static. But in Lean 3, this was really odd to use these building blocks because you have this list, right? You pick the head of the list, call a tactic, and it should create elements there. It's like the result. You have to decode the result from this list, right? And so in Lean 4, the low-level tactics are all in this meta-M monads, right? And they all have this structure. The first argument is the meta variable ID, like you can use the name of the hole, right? You have some hole. Each tactic gets a hole and returns one or more holes for you, right? For instance, the intro n, basically you have the ID of the hole, the number of parameters that you want to introduce. You can optionally give names to them, and you get back the name of the new hole, right? And the IDs of the variables that you introduced, the hypotheses. You may also call them hypotheses, right? You have all these IDs that you can use to build more complicated statics. And we have many variants of intro. For instance, intro n. If you don't provide a name, the names are going to be inaccessible to the user. This is the default behavior for intro n, but you have NP, that's intro n, but preserving names, right? It's going to use the names in the binders, and they are going to make them accessible. And this is quite useful when you're doing the revert intro idiom, right? You're going to revert things. And now when you introduce them back, you want the names to be preserved, right? And so the reverse, when you're using the reverse intro idiom, you probably want to use the static here, NP. And you have the case where you want to introduce only one variable and so on. Same thing for apply, right? You have a whole, the expression, right? The kernel expression in this case is not a syntax. And basically, you're going to try to close this hole by creating an application. You're going to fill hole, you're going to add arguments that are the new goals you have to solve, right? And this is one thing that I want to make clear, that in MetaM, you have all these building blocks that you can use to build more complicated statics.
I had a question. Why on that previous slide did you use list in the last one, but array in the others?
Yeah. This is always a dilemma. I mean, in the end, the apply is because the main customer for apply is the interactive worlds. The interactive world, you have a list. The list of goals is the goals you still have to solve is a list, right? And that's why. I mean, another way you see that usually the arrays is for free variables. When you're building interactive tactics, you never care about the free variable IDs, right? They're irrelevant. The user don't even see them. They're just used to plumb things together, right? And when you are plumbing things together, the arrays help, right? Using arrays to index. You know that you have 3 arguments and you can index them easily with arrays. You're going to see that quite often, that the meta variables we use lists because we want to plug in the list of open goals, that remaining goals that have to be solved. But for free variables, we usually use arrays because basically are more internal building blocks. Yeah, feel free to interrupt me. I'm seeing this session as a more informal thing. I mean, feel free to interrupt whenever you want.
I actually had a second point about the revert intro idiom.
Yes.
This is an issue that we discovered fairly late on, is that when you revert an intro, it changes the unique names of the variables, and I assume it's not really possible to have them remain the same because they are actually different. So we ended up having to add to the Lean 3 core stuff some ways to track those unique names so that things like case tags and other sorts of or like R cases or these these recursive cases routines, they lose track of like, oh, I reverted a hypothesis, I'm holding on to this unique name, and then later I go try to find it, and then I try to match maybe with the pretty printer name. Like you start to lose track of things.
That's a good question. I'm going to, when I switch to Emacs, I'm going to solve subst. Now we have the solution we have for this problem. We have something called free variable substitution. It's something that maps the free variable, the old free variables, to the new ones they correspond to after you apply a static. For these statics here, this is not an issue, but for instance, subst is exactly using the intro revert idiom, the revert intro idiom, and you have exactly this problem you described it. And we use this free variable substitution for handling this issue. I will show. I think, yeah, this is a good question. Right?
Maybe I've got another question, but maybe it's too early and you will answer later. But so in Lean 3, we had this dichotomy between expression and pre-expressions, and what they seem to be all.
In Lean 4, a pre-expression is a syntax. Is the syntax object. The equivalent. Yeah. I can explain why the pre-term in Lean 3 is more or less like the kernel term. Is because in C++ it's horrible to create a new type with all the gadgets you want. You want them to have some memory management for this type. You want to have some features. And as I said on Monday, Lean started by, we want to have a library to use inside of other assistants like FStar or Coq or Isabelle. Right, the front end was never a big concern. Of course, as with time we start adding hex on top of hex, but now in Lean 4 we have the appropriate. If you really want to have something that has a front end, the appropriate way you have these syntax objects that capture precisely the abstract syntax tree of your expressions, right? And the kernel terms are different beasts, right? Yeah, but the short answer is the pre-term is the syntax object in Lean 4.
Okay.
And the kernel term is expr.
Thanks.
Rewrite is an example also of a tactic that returns a more complicated results, right? It's not simply an expression or metavariable IT. In this case, is what you have the new expression, right? That you rewrote. The proof that is equals to E, the argument you provided, and the new goals, if your rewriting rule was like a conditional rewriting rule with hypothesis, the goals are going to be there. And again, it's using a list because, as I said, you have goals. We usually, when you want to switch the interactive words, you want to append them. And you have many parameters here, like you can have a similar, if you want, this is the hypothesis, that the equality, you may say, oh, I want to use the symmetry, apply the symmetry automatically. Remember that in Lean 3, rewrites may simultaneously change all occurrences of a term, right? And so you may specify which ones you want to, by default, it's all of them. But you can specify the transparency modes you can set, right? Another advantage of Lean 4 being implemented in Lean itself is that you don't have this. I've seen people in Lean 3, you had K-abstract was implemented in C++, and someone had, in Mathlib, someone had to expose this functionality to the Mathlib users, right? It was in C++, it was hidden. It's like in a black box, and you didn't have access to it until someone exposed this functionality to Lean users in the task framework in Lean 3. Since Lean 4 is implemented in Lean, everything is available. If you import the Lean names package, you're going to have our K-abstract there available, right? You can use it. Rewrite is the main customer of this K-abstract. And K-abstract is essentially implementing the idea of key matching. You're trying to abstract in a term E the pattern P, right? And we use them for computing motives. We use them to rewrite. And probably you found some use, because I saw that you exposed this functionality to Lean 3 Mathlib developers, right?
Yeah, I actually had a comment about that. We actually had to rewrite K-abstract inside Lean 3, which was a little bit painful because a lot of the tools for doing so weren't, there wasn't that much that was exposed. And the reason was that the occurrences was, I forget exactly how the issue manifested, but it would pick out like it would pick out like all occurrences of the third thing that it found or something like this. So when Scott was trying to implement this N3 write tactic, he basically needed a way to say, okay, I've got this term, and then I want to replace a single thing in it, not all occurrences of that thing. And for that, apparently there wasn't any setting of the occurrences parameter that would actually cause that behavior. Do you know whether the behavior of the occurrences acts like that kind of nth, or is it like what Lean 3's K-abstract is doing?
Well, it's a different implementation. It's hard to tell what was going on in Scott's example. Well, one thing that if our K-abstract is not good enough, one good news is K-abstract is really small in Lean 4. If you need to copy and paste and adjust to your own needs, it's not going to be a big deal, right? I mean, I think the effort also by implementing everything in Lean is the effort of adapting something we wrote to your needs is way smaller than porting C++ code to Lean, right? I can't guarantee that it's going to do everything you want, but if it doesn't, you can create your own version. I can show the K-abstracts after. It's pretty small, the code. Then comes the term LabM. It's on top of MetaM. You can see here that we're extending the MetaM monad with more states and more context, right? The ambience. And in states now, we have like synthetic meta variables, messages, the nested let's rex, you have two lifts, right? You have file name, file map, you have a lot of information, flags to disable the auto-bound implicits and so on. But the main methods that's provided by this term LabM is this lab term, that you get a term, right? A syntax, what we call pre-term in Lean 3. You get expected type. I will talk in a moment what catch postpone is, and you return an expression, right? If you're writing your own elaboration function, you are probably going to use this lab term to elaborate nested terms in your notation, right? This catch here, postpone, as I said, in Lean 3, you can postpone the elaboration. By default, what happens is if you don't say anything, LabTerm is going to do the following. It's going to try to elaborate the syntax objects. If it cannot do it, it's stuck somewhere, it's going to create a meta variable and put a task saying, elaborate the syntax objects later to fill this meta variable. That's how it works. But this is not good enough in some scenarios where you have your notation that has to elaborate some nested term that if it cannot be elaborated immediately, you want to postpone your whole notation. You don't want to get a beta variable back. That's why we have this parameter there. And it's useful sometimes. But if you're using this parameter, you're probably doing something very advanced already in Lean 4. It took me a while to find an example that would be not too trivial, but at the same time fits in one slide. I found this one here. It's yet another anonymous constructor notation. I just using a different bracket just to make it different from the default one we have. The default Lean 3 and Lean 4 anonymous constructor notation only works if your inductive data type has only one constructor, right? If it has more than one, you want to say, I can do it. This one here, it's slightly different. He will pick the first constructor that has the correct number of arguments. I mean, if you're providing 2 arguments here, it's going to look for a constructor that has 2 arguments, and you pick the first one. I don't think this is a good idea for an extension, but I think it will highlight many features of the elaborator, right? The first step
wouldn't have the right associating behavior that the anonymous constructor has in Lean 3. I mean, when we use the anonymous constructor notation in Lean 3, we can do nested things because there's this association.
Yeah, actually, it's a good question. Do you think this is a feature or a bug? This is what's debate. I was very clear in Lean 4. We thought about should we still support that? This creates more confusion.
We use it all the time.
Use all the time this stuff.
Well, we certainly use the anonymous constructors for single constructor inductives all the time.
Yes.
But
the chaining. Patrick was
for chaining. Yeah. We use that all the time as well. Yeah. Like exists, and destruct.
Okay. Cool.
Yeah.
Cool. Use this. Okay, yeah, we can. This is easy things to add. It's not a big deal, but let's see this one here, what it does. The first thing, I declare the notation, right? Basically, I have this kind of brackets. I have a term that's a bunch of terms separated by commas with a potential trailing comma in the ends. I'm giving a name to this syntax object. It's calling a citor, anonymous constructor. It's important to give a name here because I want to reference this name when I'm defining an elaborator function for this notation here. I'm saying I'm building here a term elaborator for a citor, right? This piece of code doesn't need to be inside of Lean. Right, you can create a file, you say import Lean and write this code, and you're going to have your anonymous constructor working there. Then this is a term elaborator, right? A term elaborator gets a syntax, an expected type, and has to produce a kernel term. The first thing I do a match syntax, where I match against this syntax. Here's what Sebastian described. It is exactly what Sebastian described yesterday for macros. I'm extracting here, args here is an array of all the arguments you provided. They are all syntax objects. Then the first thing I say is get the constructor, given the expected type you provided me, give me back the constructors. I wrote a very simple function here that's if the expected type is not available, I throw an error. If it is, I try to normalize the type, then get the head symbol. If the head symbol is a constant, I look into the environment. If the environment is an inductive type, I return the list of constructors. It's just boilerplate. This is not the parts I want to show you. I want to focus on this part here after we get the constructors. And we're going to traverse is a list of the constructor names. I'm going to get the constructor information. Basically, I check if the number of fields is equal to the number of arguments. If it is, I'm going to use being a little bit unhygienic here. I'm creating a term saying this is the name. I make cdents from The from is just to provide position information. I'm creating an identifier called with the name setor name, using position information, stealing position information from the syntax objects that I got as an argument. Basically, I'm going to get the position information of the brackets here. That's what's happening here. I'm creating an identifier called setor name. And here I'm bypassing hygiene, right? I'm creating an identifier manually, right? And I'm putting there all the arguments. I'm like splicing the arguments inside of these syntax objects.
Oh, what about this is explicitly bypassing the hygiene? Like, is there some sigil or something that's needed in order to say, I don't want hygiene here?
No, it's just I'm creating the identifier manually and splicing it together. You see that I have the dollar here. Mm-hmm. I'm saying I'm splicing a syntax object here. And this syntax object I created by using this function makes the ident from, that creates an identifier.
So that if you were doing hygiene, would this just be like you use some kind of binder inside that quotation?
Yeah, if suppose that here hygiene doesn't, you want to bypass hygiene because you're saying this is the name I want, right? If I had hygiene is really useful when you are expanding to a macro where you have a temporary variable or you have a temporary declaration that you want to avoid any collision. But here's in the case that you want that constructor, right? Okay. Then now we say with macro expansion is just a helper combinator that says, okay, this is the before and after, put it on my macro stack. I'm going to elaborate this term here with the macro stack updated with this syntax and new syntax pair there. And I'm going to call a lab term new syntax with the expected type. This is completely optional. The only difference if you skip this with macro expansion is that if the user will not be able to see this step, this macro expansion step, if they ask for the macro stack trace. It's up to you to decide if you want to include this kind of information or not. This is the whole...
How does this handle like... I guess you could call it like precedence hygiene or something, like where, like, let's say I had some kind of high precedence, like a minus sign or something in front of the entire application. Like you just constructed a space separated list of stuff. I expect that this is actually something more complicated than that.
Oh no, yeah, we have the parser. We execute the parser here. The parser has support for the dollar. Right? So you are parsing a term and build a syntax tree and splicing these dollar things inside of the syntax tree.
So if there was a minus sign in front of this full syntax object, that minus sign wouldn't attach to the first identifier in this list.
No, yeah, the minus sign will behave exactly like it behaves when you're writing. You follow all the precedence rules in Lean. Right, that's associated with the minus sign.
Because if we were doing like a textual replacement of this, you know, it had brackets around it before, and so you'd expect that the minus sign would apply to the whole thing. But if I just textually replace it by a space-separated list of identifiers, then maybe it'll just apply to the first identifier in that list, right? And then it'll like interpret it as an application of something. And that's probably not what I want in this particular example, right? So. Is it the fact that you say new syntax is, and then this thing is like a group, and so this is always going to be treated as a group now, or?
No, you should focus on this line here. Your question, the important line is this one, right? So we are going to parse it as you can, when you're providing these dollars, you can tell what this dollar is. You can say this is an identifier. And so Lean knows this has maximum precedence because that's the precedence for identifiers, right? If you write, for instance, $X plus $Y times $Z, this is going to be plus X times YZ, right? It's the exact syntax tree, right? You get when you parse this thing. Right?
Well, I'm wondering about the things that are sort of outside, like if the user, they wrote, you know, minus sign and then open brace, vertical bar, and then the terms, and then the vertical bar, close brace, you know, and so my syntax is getting called because, you know, it's got the curly braces, but I'd like in this, you know, if I'm writing this function, I'd like to replace that group, the entire curly braces thing, with another group. And I don't want it to be just a space separated list, whichever, if the user were to directly write, would cause, you know, the minus sign to apply just to the first.
No, it's not. When you expand, you inject, you are replacing this syntax tree with the new one you created.
Okay. So the parsing has already sort of happened, I guess?
Yes, yeah. The parsing has already happened. When you are gluing things together, the parsing already happens. That's why, I remember that yesterday or Monday we were talking, I told you that we have a parenthesizer. The parenthesizer is really important because of that. When you expand things, right, you may create things that cannot be reparsed, right? Suppose that you have a macro that's X expands in 2 plus 3, right? And you have X times 5. When you expand, you are going to have the syntax tree, right? You are putting the times there. When you print prints, if you print prints naively, there's no parentheses, you are going to get a different meaning, right? You're going to change the meaning. That's why in Lean 4, we have a parenthesizer that will add the parentheses to make sure that when you print prints, you are getting the exact same abstract syntax tree, right? Not exactly the same. You still have the extra parentheses, but the meaning didn't change, right? But you should view all these operations that are not operations on strings, they are operations on syntax trees, right? The parsing happens also at compilation time here. We are not parsing at runtime. When you write a quotation, we parse the quotation at compilation time. At runtime, we are performing abstract syntax tree, syntax operations, right? Splicing things together, but you're not parsing anything at the runtime.
Okay.
Now, if we try our...
Could I ask one more quick question about that? This will be fast. The termalab annotation at the top. So you're already matching the syntax on what you defined or to be. So what does the termalab annotation do?
Oh, the termalab is the first thing. You are registering inside of Lean that this method here should be invoked when you are trying to elaborate this kind of term here.
Okay.
Right. The match syntax, you could imagine, and actually we have a macro that does that called LabM that you can basically combine, expands in a definition of this form. I can actually show later the LabM that's, I think, does what you're thinking. This is, keep in mind that the match it doesn't need to be in the top level in a term elaboration function. You may have several, it doesn't need to be in the top level, but we do have a LabM macro that's giving a pattern. You can give codes that is executed when this pattern is found. But this macro is expanded into that, in this thing here.
Makes sense. Yeah, thanks.
But basically this is an annotation to Lean saying, this is a term elaborator. When you see a syntax object with these kinds of annotation here, asyntor, you should execute this function. You are telling the elaborator to do that. Now, if you try this example, the first one, listnet, you're providing, using the notation without arguments, it works, it's the list new. Now you have test 2, you have a pair, you're providing 1, 2, it's working. And now you try a more complicated example, and it says expected inductive type application. It produces an error message because the expected type is not available here. is exactly, it's none. The expected type in this scenario is going to be none or meta variables, not known. And it's producing this error message here, right? Let's see if how can we improve that? This is a common idiom that you want to elaborate something only if the expected type is known. And here's an example. You have this method called try to postpone if the expected type is none or is a meta variable, right? This is going to tell the elaborator what happens here is that if the expected type is not known, it's going to interrupt execution and it's going to resume later if possible. If we add this extra line, now our 3 examples work. And now this example looks simple, but a lot of stuff is happening here to be able to allow us to elaborate it. What happens is when we get to the lets, here we don't have the expected type. We are going to stop, right? Create a meta variable, and we will tell the elaborator, try to elaborate later. Okay, it stops it. Then we start elaborating this expression here. And we have x. We're appending x to itself. This is a heterogeneous application. We don't know the type of x. Then we are stuck again. The default instances we mentioned on Monday kick in because there's nothing else for us to do. Then the default instance for the heterogeneous append is the homogeneous append. Now we decided that we should use the homogeneous append operation. We can propagate the least net type to its arguments, right? We now know that x is a net, is a list of nets, right? Now that we know that x is a list of natural numbers, we know that this term here is also of the type list net. We can elaborate it and everything works, right? You see that the elaborator does a lot of stuff behind the scenes. Now our final monad is the PatrickM. Well, not final, I have another one. Sorry. This is the PatrickM, is the one that you're familiar with. It extends the term LabM, right? With more states. In this case, the state is the list of goals that remain to be solved, right? And you have the context here is just the main meta variable ID, right? The initial hole you started, the static, where you started the static. And the main methods of this monad is called eval_static, right? It's an evaluator. We're just evaluating the syntax, right? You can view it as an interpreter for syntax objects that represent statics, right? And he's basically using the statics we have at MetaM to fulfill the user requests, right? I have a very simple example. That's the intro, right? Basically here, this is a built-in static, and let's see how we handle it. We do a pattern matching. If it's an intro without arguments, we treat it as we have this auxiliary method here, intro step. It's like intro without arguments is like intro with underscore, right? If intro with one argument, right, one identifier, we introduce, this is that name that the user is providing. We call intro with this name. This meta intro here is the static I described before that is living in meta M, right? Now if intro with underscore is the intro with the underscore, remember that we are trying to be hygiene. So if the user is not providing names, they're going to be inaccessible, but we still want to allow people to be unhygienic with that option. We describe on Monday, right? Since when you are disable hygiene, in this case, the names are going to be accessible and we're going to use whatever is there, right? Of course, if there's a collision, it's going to behave like in lin3, where we add underscore 1, underscore 2 to avoid collisions. But let's see the more interesting cases where intro here is a term. It's not just an identifier. It's since you are pattern matching sequence, is going here. This case here is reached when the term is not an identifier, right? And what we're going to do intro age. Age here is a new name. Hygiene guarantees that it's going to be unique. We are going to match on this age using the pattern that the user provided, right? This is going to create a new sub-goal. And before allowing the user to solve the sub-goal, we're going to clear age, this auxiliary name we introduces. Even if the clear fails because of dependencies, forward dependencies, this name is going to be inaccessible. That's how the pattern matching works with intro, right? It is using behind the scenes the age. And now the final case is where the intro is not just one element, but multiple, right? So you have, when you use intro age1, age2, age3, or different patterns, right? And it will chain them together, right? It's going to, when you have more than one, you expand into two intros, right? The first one and the rest, right? And this is the macro for intro, right? It's very compact. If we improve the match tactic, we automatically improve the intro tactic. We support intro with, it's like the fun bar. I don't know if you saw this notation where you can say fun and you do the pattern matching immediately. There are many cases we can do that, but it's a different notation actually. They are both called intro, but they are defined completely independently of each other. The basic intro is just these 5 cases here.
When does this run exactly? Like, is this it seems kind of like a mix between a macro and like tactic time execution.
Yes. Well, how it happens, the tactics are executed, I mean, when you say buy in Lean, right? So we create a meta variable for this buy expression, right? And say, this is the tactic code, the syntax code of the tactic. We store this information, right? Eventually, we are going to we are going to try to fill all these holes, right? After we elaborate the rest, the surrounding term, right? After we elaborate the surrounding term, there's these holes missing. We are going to execute the tactics using this eval tactic method, right? Eval tactic is going to, whenever he finds he's going to get the syntax node ID, and you would look into its tables. It has a table of syntax node ID to this kind of method here. We have for begin end, well, we don't have begin end, but we have sequences of tactics. We have intro, induction. Each one of them has a handler like this one here. And it's a recursive function. You see, I'm calling eval tactic recursively here, right? And you keep doing that, you're filling the meta variable with something, but you're creating new meta variables that should be filled. You keep executing this eval tactic loop. Eventually, they are all filled, right? You say, oh, but the tactics are interpreted. Yeah, the connection with the front end is interpreted. The tactics, the working horses are all compiled, right? For instance, if you implement ring, you're going to have a MetaM ring that you're going to compile in a plugin, super efficient. This is compiled. The front end, when you type ring, you have this driver here that is, this is the ring tactic. If it has parameters, you're probably going to decode the parameters and then call your ring tactic in MetaM that's compiled and super efficient, right? Here you can use just a driver to call the actual implementations.
So what is the built-in tactic annotation is doing? Is it somehow a special tactic?
We have a bootstrap. Let me. I have an echo, so I can hear myself. Okay. The built-in. For every, like here, TermLab, we have built-in TermLab. We have the same thing for tactics. When the user is writing their own tactic handlers, they just write tactic. But for us, for bootstrapping Lean, we need to have a built-in tactic. For instance, I don't know if you, probably some of you remember in Lean 3, until we define the static framework, we can use statics. For instance, when you define the natural numbers in Lean 3, the basic properties of natural numbers, you can't use statics because the statics haven't been defined yet. This is a much bigger problem in Lean 4 because we have built-in, we're implementing Lean itself. For instance, the elaborator for application has to be built in. I can't wait until we define a lot of stuff to be able to elaborate applications. And having built-in static is handy. We can use statics after. The only file where we cannot use statics is prelude. It's the first file. The second file we can start using statics. It is so handy for us, for instance, for the well-founded recursion file, WF in Lean 3. It's a pain. It's a pain. It's horror. It's a nightmare. Using statics is trivial. It's like 5 lines each here and there. It's just 5 lines of code. I mean, and having built-in statics allows us to do that. It's just, you can ignore. Only if you are modifying Lean itself, you have to use the built-in prefix.
What does it actually do? Like, is it saying that it's going to go into that the C code version? What is it, stage 0? Like, how does that work?
Yeah, we have tables like hash maps that are global references, right? That are populated when you turn on Lean, you start the Lean process. The first thing it will do is an initialization process, and it will populate all these built-in tables. The stage 0 thing that you mentioned is important because the effects of a built-in static can only be observed after you do the update stage 0. Because you're going to, basically when you say update stage 0, you're going to copy the current, you take a snapshot of the current state of the system to this stage 0 folder. And now the initialization process for the Lean we use to build Lean will take in consideration this new built-in static you added. For when you use TermLab here, you are adding an entry inside of the Lean environment, right? This doesn't work for us because of these bootstrapping issues. You want to use things like the intro static before you even define the static framework. So there's no way for us to populate the environments since the things we care about don't even exist yet. That's how the built-in. I think most users can ignore the built-in thing. It's just a nightmare that Sebastian and I have to deal with in our lives. But we have built-in statics, we have built-in parsers, and you have built-in term elaborators.
But does it mean that those would be harder to replace? Say, if I write my version of intro, will it be?
Oh, you can always replace the built-in. You can always replace. You can always define your. The first thing, there are 2 ways to extend something. You can add an intro that supports a syntax that's not supported by the default intro. This is one possibility. There's no overlap. But even if the syntaxes overlap, you can say that your new syntax has higher precedence over the built-in intro. It's like the example, remember that on Monday we shown, or Wednesday, I don't remember, but we shown an example where we redefined the addition with higher priority. It's the same thing. You can do the same thing for the statics. You can give a higher priority and you will replace the built-in intro.
Okay.
Right.
That's nice.
Well, it's not really replacing, but it will always be used instead of the built-in one, right?
Because in MATLAB, Mario wrote a fairly sophisticated recursive intro tactic. It's really nice. And we would like to call it intro.
Well, I think that for the most part, so intro, as you saw, intro supports cases, right? So actually, it's possible that, you know, our cases and our intro can just be replaced by the built-in versions now. I mean, our cases does have a lot of features in it, so we'll see whether they're all in this version. But
I mean, it's huge. I mean, I'm ready to believe that Lean4 is more efficient, but I mean, the RCases file in mathlib is several hundred lines long, and I mean, it would be great if you can do the same with those 20.
Yeah, for sure you can. For sure you can. I mean, yeah, we designed to allow this kind of application, right?
Oh, great.
You can put higher priority. You can define your own handler. You can have your intro, recursive intro compiled in a plugin if you want performance. Yeah, all these scenarios are supported. The command LabM is a version, is a monad for elaborating commands. Note there is no meta variable context. You have environments, but you have the messages, the scopes, it's all there. And basically it's something that gets a syntax and doesn't really return anything, right? It just has effects, like the effects are usually updating the environments with new declarations or effects that are introducing new messages when you have the check command as an example, right? But we really not producing any results direct, right? We elaborate commands because of their effects, right? And here's a simple command. It's a built-in command, but you can also define your own check if you want, right? Another thing that you don't need to create new syntax to override something we have built in, right? For instance, you have here the check command. Suppose that you don't want to create a new syntax for check. You just want to intercept check. You can add in your environments. Command is you skip the built-in. It's going to be command lab lean.parser.command.check def lab my check command lab, and here you give the code for your elaboration function for your check. Is going to be used instead of the built-in one. You're going to intercept the built-in one and replace in the one you provide is being used instead, right? But I can go over some useful things in this. It demos a few useful things, like we are parsing, you are matching the commands, we're extracting the term. We also want a reference to this token here for producing the information message. We use this combinator saying, I don't want to modify the environment. Whatever check does, I don't want any update in my environment. I want to execute check. Some terms may introduce auxiliary declarations in the environments. You really don't want them because they are just junk, right? And so I used to say, without modifying the environment, do this. What is this in this case? We run the term elaborator, right? So you're going to run a term elaborator function here. You're providing here a name, a surrounding, a name is this artificial name. We're going to discard anyway. But sometimes you create auxiliary declarations for nested terms. They're going to have the prefix check in this case. Then the first thing you do is elaborating the term here, right? Without an expected type. Then we say synthesize everything that is pending. If this is going to produce an error message if there's something that is stuck, right? There's some type class you can't handle, something like that. Then you want to convert all meta variables, universe meta variables, you want to convert them to parameters because you want to produce a nice error message, right? A nice information message. Then you instantiate all meta variables in E. Then you infer the type of E. And if there's no syntactic sorry there, right? Syntactic sorry is the same idea that we have in Lean3. If there is an error, we decided that it doesn't make a lot of sense to print the type. Sometimes the information is really, it's a meta variable, it's the syntactic, just the syntactic meta variable, right? So we don't print information in this case. Otherwise, we log this information, the E colon, the type, right? This is using creating a message data. This is not creating a string. The mbang here is the notation for creating a message data. It's a message containing the expression E and the expression type. When the user requests, the language server protocol requests this information, it will print these two expressions, right? And that's how the commands check works. It's easy to create your own variant of these commands if you want. I'm going to switch to Emacs just to show simple things. Let's see if I can. Here's the subst, right? Can you see my Emacs?
Yes.
Yeah, this free variable substitution is exactly what I was telling Mario earlier, right? It's like here I have the subst core is like a core function that's very low level where it provides a whole, the meta variable ID. I provide the hypothesis ID that contains the equality I want to use to substitute. There are if I want to use the symmetry of this equality, and I get a free variable substitution as an argument. By default, it's an empty free variable substitution. I can optionally ask the static to try to clear this hypothesis if possible. And finally, you return a new free variable substitution and a new whole, right? And this free variable substitution is what we use when you are trying to keep track of the free variables that you rename, how your hypotheses were renamed, right? This is at the internal ID level, right? It has nothing to do with the username you see as a user. Yeah, that's what I want to demo here. I thought also would be interesting to show how a more complicated static is implemented. For instance, we have the simp static. We start declaring some types like simp, keep creating for each nested term some result that is the new term and an optional proof if it's not a proof by reflexivity. You have a context where you have many configuration options, the context of the term you are rewriting that we call the parents, and the set of simple lemmas active at that time. The state is a cache and the number of steps performed so far. And the simp m monads is something, we're just extending the meta m monads. Then a step is something that can, when we call a user function that may say, yes, I rewrote and I want you to keep visiting the results I produced, simplifying the results. Or I'm telling you, I rewrote the term you gave me and this is the result, consider it, assume that we are done. Don't try to visit it again. The user can provide methods for performing a pre-visit before you visit just the subterms of a term. You can execute this user function. You can execute this user function after you visit. You simplify the expression. The user can provide a function to discharge verification when you have simple lemmas that are conditional rewriting rules. And you package everything in another reader T, adding more context to the simp m monads. That's the internal monads that we use to implement the simp static itself. Then we go to this rewrite step. That is not like the rewrite static, but it gets a discrimination tree of simple lemmas. Right, you get an expression that you want to simplify, that you want to rewrite. This is a single step, it's not the simp static, but one step of the simp static that you get a subterm, the discrimination tree containing all the simple lemmas, and you're going to get the results, right, back. And you have the discharge. If it's the simple lemma you select has hypotheses that have to be fulfilled, this discharge method is going to be used. And the main simp function is like that. You have many, you use the where to group all the auxiliary methods. You have the main loop. You have a dispatch for the different kinds of expressions we have in Lean. I will try to focus on one simple case, like the simplified lambda, right? So what happens here? The first thing we say, with parents, we're updating the ambience, right? The lambda is the parents now. We do the lambda telescope to get all the binders, right? XS. Now E is the body of the lambda. We call this with new lemmas XS, because if you're doing contextual rewriting, some of these hypotheses, these arguments of the lambda may be equations that you want to use as rewriting rules. And this with new lemmas is defined here, like basically saying, oh, if it is contextual, do this, otherwise just execute F. But if it's contextual, I want to get the set of simple lemmas. I want to traverse the XS. If one of them is a proof, I want to update the set of simple lemmas using this X, right? Basically here in this example here, even if your X is just a proposition, right? It's a proof of a proposition, like that's not a equality, you can still use it as a rewriting rule that rewrites to true, right? That's why we don't check if it's a equality proof here.
Can you say again what with parent does?
Excuse me?
Can you say again what with parent does?
With parents, for most users of SIMP, I can tell you why we have these parents. I mean, we have a context here. We have this parents field in the context of SIMP. I should probably explain why we have these parents. Is the context when you are? It's like you have a term. These parents should be like the context of the term, right? That's your you could see the parents term of this subterm, right? Why you may ask, why do we have that, right? Suppose someone is implementing a polynomial, a very efficient polynomial simplifier. And they want to call in this pre-method here, or in the post, they want to call this polynomial simplifier from simp. Makes sense? I mean, you have some procedure for simplifying polynomials.
This is like in Isabelle's simprox?
Yes, you could use a simproc, but you could claim this is infrastructure. If you want to implement something like simproc, you could use that. The pre and post you can put whatever you want there, but it's useful to know the surrounding term. First is for polynomial simplifier. You're going to simp is going to keep calling the pre and post. Probably you only want to call the polynomial simplifier if the surrounding term of this polynomial, right? This is an expert. It's not a polynomial itself. Right, because suppose that you have a plus b plus c, you only want to call the polynomial simplifier for the roots a plus b plus c. You don't want to call it into the subterms, right, of this polynomial that are also polynomials, right?
Yeah. Okay.
Do you see this scenario? Right. So you don't want to keep calling the polynomial simplifier for all sub polynomials of the main polynomial, right? And when you represent the polynomial as an expert, you have this phenomenon, right? You have many polynomials inside of a polynomial, right? And one way to avoid that is just check these parents. And you say, oh, if the parent is an expert that is a polynomial, morally a polynomial, don't use a polynomial simplifier. It will be used on my parents. And we are going to get everything simplified there. That's why we have these parents. Support scenario. If you don't care about adding this kind of pre and post that's calling a polynomial simplifier or calling some kind of simplifier, this is irrelevant to this parent field. Then the lambda, you're going to simplify the body of the lambda. Then you're going to create a new lambda using the x-axis, right? So now it's a lambda expression again. And now we check, oh, the result has a proof. Let's see if the result has a proof. If it doesn't have a proof, this is just a proof by reflexivity, right? We just return x per e mu is the new lambda we created. It is equal to e because by reflexivity, then we don't plug in anything, any proof there. If we have a proof, we should use funnext to create a proof for the new lambda, right? We folds in reverse, right? You have the body is equals the old body equals to the new body. This is the age, right? And now you keep applying funnext in reverse order to build a proof that the two lambdas are equal, right? If their bodies are equal, right? And that's the result. That's the result of this simple lambda, right? It's the E new, that's the new lambda. And the proof P here we constructed by using a folds in reverse, right? On the XS. We have similar functions for application, for simplifying arrow, but this is a good example on how to do things in Lean 4. And after we do all that, we have like the simp entry point, that's a meta M, right? The last step is just to connect this to the front end. And we do that by writing a static, right? There are, as you know, in Lean 3, there are millions of parameters, the simp static. You're going to decode all these parameters and you're going to keep calling. For instance, you have the simp targets, you can simp a hypothesis, you can use the hypothesis to simp the targets. And you have to, the user may provide new simp lemmas that you have to decode and add. It's the same thing, right? This is the code that is connecting the front end that has a simp of many parameters to this static that we just demoed, right? I can show you the actual call here to that simple. Here it's being called the simp static that we were browsing a few seconds ago, right? And that's how you do it, right? You have the most low-level statics like simp implemented in MetaM. Some of them are configurable at the MetaM level. And then in PatrickM, we connect it to the interactive world, right? Basically, that's the last example I had. I mean, I'm happy to answer questions about this process, but that's how you connect things. If you want to write your own simp, that's the way to go.
Well, Leo, somebody's got to say it. It's really very beautiful.
Oh, thanks.
Yeah.
I have a question. So if PatrickM is only for the interactive tactic and you're meant to use MetaM for the internal stuff, why do you still need to say PatrickM unit? That it does nothing at the end. So
okay. Yeah. We have a alias static. Is an alias for syntax arrow PatrickM units. Okay. Right. But sometimes we use static, for instance, here, notice that if I had written static, it's not quite right? I don't take a syntax as an argument. Right? I take a configuration plus a set of simple lemmas. It's something that's, for us, a static is something that gets a syntax and arrow PatrickM units, right? And we have a name for that, right? That's why we use it here, just static. But sometimes you,
sorry.
What? Go ahead.
Goes to the Lean 3 interactive tactic and tactic.
Yes.
Like
yes.
I think there's actually command. I don't know that we've ever used command in MATLAB, but it is actually a definition which I think abbreviates tactic unit. So that's, I guess, the nearest approximation to what tactic is now.
Yes. Yeah, the commands stuff in Lean3 is more like afterthought, right? The static monad was not built for allowing people to create user-defined commands. But since that was the only thing that was there, let's use it to allow people to write commands. It's like afterthoughts, right? So here we have the commands LabM. That is what you want to write commands, right?
So command LabM is like tactic, except it doesn't have any meta variables involved. Is that the idea?
Oh yeah. Well, command LabM it doesn't have meta variable context or meta variables there. It doesn't have local context also. There's also a difference in Lean3. When we say variables, right? The variables I elaborated once and for all for that section. In Lean4, we elaborate as a sanity check, but we throw away the results. The variable declarations are going to be re-elaborated for each command their users. And this is useful because the variables are elaborated only once in Lean3, it creates confusion like, if I have a block of variables in my declaration, if I copy them to variables, the behavior changes, right? It was not clear for the user what was going on. It's because when it's inside of the declaration, the context you are affects the elaboration of these variables, right? This was one confusion users had. We noticed another confusion was you have a variable here, they are elaborated, and you couldn't understand why there were things missing. It's because you didn't have sufficient context there. Another confusion was you use a star there, right? Yeah, you know what I'm talking about. All these problems are gone now right. Yeah.
I had another question about parser versus tactic. So in Lean3, there's basically two monads that are exposed to user code, and that's the parser monad and tactic monad. And in particular, the parser monad had access to some information that wasn't available in the tactic monad. And you could like inject one into the other, but not the other way around. Which meant that there were, in particular, things like the namespaces and other sorts of contextual information about like where you are in the file that was not available in a tactic, or like the declaration that you're currently elaborating and things like that. Is that stuff all available in tactics now because they're on this sort of hierarchy of
Yeah, well, the parser itself in Lean, in principle, people can call the parser from a tactic, but I would claim they're misusing the APIs, right? We have syntax objects in tactics, right? They already have been parsed. All this quotation business is just you're combining syntax objects with these quotations, right? There's no parsing at runtime.
Yeah, I mean, I definitely agree that this is a misuse of parser. It's just that parser was the only thing that had access because it was like reading from top to bottom, and it has all this information, and nothing else knows about the information because it gets thrown away.
No, I understand. I mean, this is what you had. Let's use it. It's the only thing available. But in Lean4, we don't expect people to have to call the parser from from a tactic, right? It's important when you're designing a tactic to keep in mind if you need to manipulate syntax objects and elaborate them, or you're just manipulating kernel expressions. This distinction is important, right? For instance, a tactic like refine, for sure it exists in interactive mode, right? Because you have some term that the user wrote that is a syntax object, and you want to elaborate this syntax object in the context of in some local context inside of your tactic. This is something that should live in the static M, because you have the capability in tactic M to call eval term that converts a syntax object into a kernel expression, right? But on the other hand, when you're doing things like simp or ring tactic, you don't really have syntax objects anymore, right? You have collections of simple lemmas, or you're applying some procedure, right, for normalizing a term, a kernel term expert, right? Yeah, it's important to have these things in your minds when you're designing your tactics. In Lin3, this is all mixed. As you point out, even the parser sometimes people could invoke, right?
So the information about things like namespaces and sections and where you are in the file, is that in MetaM?
We have, this is one thing that's in MetaM, we have some, I can show you. There's not everything is there, but for instance, for resolving names, we decided each was useful to have in, even I think in CoreM now we have, let's see, put here. Yeah, for instance, these two things here is what's, you have the current namespace in the set of open declarations is available even in CoreM, because that's what you need for doing name resolution, right? We have probably here somewhere the resolve name interface. The CoreM implements the resolve name interface. Being able to resolve names, we try to initially to have it only on LabM, but this is handy in many scenarios. It turns out that now even CoreM can resolve names. Okay. But information about sections, this is in comment LabM right now. Okay. If you want to see, we go the commands. You have here, you have scopes with the open declarations, in the scope, the namespace, all this stuff. And the states, you have a list of scopes, right? If you want, for instance, that's where commands people implemented in mathlib, you can do it by just getting the scopes and printing all the scopes there. Everything you want is there, right? The variable declarations as syntax objects, you can print all this information, right?
Do you know how it would, like, if we were to write something like the docgen, do you have any suggestions for like how we would get access to information about like all the different files? Like, should we run something at the bottom of each file to gather information about the declarations, or is this information all in the environment? Like, you know, if we want to produce for each file, here's a list of all the declarations, here's some, you know, information about how they've been situated. Maybe here's where a section starts, that kind of stuff.
I don't have a good answer right now. We are adding more. For instance, Sebastian last week or this week, I don't know, I'm lost in time now, with this breadcrumb here. He wrote a parser, he used the parsers to extract this kind of information here. It's like, I think this, I forgot, maybe Sebastian can help me. What's the commands, Sebastian, to see the UI, something?
I menu, something, the UI menu.
I menu, yeah. Oh yeah, you can see the structure of the whole file here. You can jump.
It's still a bit prettier in VS Code.
Okay. Yeah, but you have this index here. It's probably, if you want to use documentation, getting this as a reference, this stuff that Sebastian implemented would help. We are going to have provides the doc strings, easy access to the doc strings, although this is a to-do in our issue tracker, but we'll be there. But seeing how Sebastian implemented this code, if you want to have the structure of the document, this is a good place to look at.
I mean, on some level, Iwan is just the syntax tree for an entire file, right?
Yes, that's exactly what Sebastian is doing here to create this breadcrumb stuff.
If that's
Yeah, and in this case, it's actually a bit more complicated because we want to return it as soon as possible for the language server. So we actually parse ahead. I think Leo has mentioned that on some other occasion, which probably, I mean, for DocGen, it doesn't have to be instantaneous. So you can't just process the file completely. And yeah, I mean, could even be that the language server protocol is already sufficient for that. But most probably you just want to do the same thing the language server is doing, which is to just drive the whole front end yourself, which is like what do saying parse, elaborate, and so on. And then you have the entire syntax tree.
Yeah, keep in mind that we have in Lean, you can create, it's not hard to create your own standalone application, right? You can create a Lean file that you import Lean, you add your own main function, right? For your, for what you want to do for a DocGen tool, where you keep calling we have a lab commands here. Right, you can't keep calling the command elaborator and tracking all the syntax objects that are being. Oh, I'm showing the linter. Sorry. You can keep calling lab commands and processing all the syntax objects, calling the parser. There is a file called front end that's for the standalone Lean compiler. But the Lean server does exactly that. The Lean server, the LSP server, he goes there, intercepts. I mean, he's not using the same main function we have for compiling a Lean file in batch mode, right? If you want to create a DocGen tool, it's the same idea. Go there, you can implement your own function. That's a standalone application, but it's not built from scratch. You can use these building blocks we have for elaborating commands, for parsing files, right? And it's going to be super faithful. Even if the user define a bunch of macros, commands macros, you will still be able to parse the file precisely, get all the information precisely, right?
I've got a question which is much less technical. It's not about metaprogramming, but it's about elaboration. Did you think about making the dot notation more powerful? Because in Mathlib we have many structures extending other structures, and so if you want to get to access a field, you have shortcut with the dot notation. But if you want to use the dot notation for accessing lambda in the namespace called
yeah, let's see. I think we have what you want already. Suppose that you have this here. I have a structure B where Y is an X, and you have here def a full. Okay, double X. Suppose that you have that. And you want to say, for instance, check X and Y. When this is a B, but you want to say double X.
Should B extend A?
Your B is not extending A yet.
What's
B is not extending.
B only has one.
Oh yeah. Sorry. That's what you want, right?
Oh yeah, great.
You see, I mean, here, if you see the result of let me put the flight check.
Patrick, Lean 3 already has this.
Mm-hmm.
Though.
No, so this is not. No, if it already works in Lean 3, then this is not what I want. Because what I want doesn't work in Lean 3.
Are you maybe you're talking about like using coercions or something else instead of extends? If you write extends directly in Lean 3, what will happen is that it gets elaborated into a call to like b.2a.XX, right? It just sort of, when you print it out again, it shows that instead. I think, like, if you have instances or anything other than extends, Lean 3 certainly isn't going to be able to resolve this. Is that what you're thinking of, Patrick?
It's weird because then what's the problem? Oh, I'm pretty sure it doesn't work. So okay, maybe I should think about a precise example.
But things that work in Lean 4 that I'm sure do not work in Lean 3, for instance, for instances. When you have classes and instances, if you want to use the dot notation, you have S is colon has is monoid, right? And you want to use the S dot notation, doesn't work in Lean 3, right? In Lean 4, this works.
Okay.
But so you have been talking to extending even more the dot notation.
What does the extends keyword do? Does it actually put is B a field of is A a field of B now?
Yes, yes. It's like the Lean 3 Lean 3 has
the new one.
The same encoding, yeah, the new one, yeah.
One thing I've sometimes wanted with the dot notation, I don't know if it's worth implementing it, is if you suppose you have a for all statement with as conclusion a structure, and that has name F, that you then can write F dot and then a field of the structure or something. That is sometimes useful.
Okay, can you say it again? You have a function that returns a structure?
Yes, and then you might want to write F dot and then a definition in the namespace of that structure. But I don't know if that is a useful default.
Let's suppose that we have something like that. That's x y equals 20. In Lean 4,
and so maybe in the namespace B, you have something that takes functions from net to B as an argument, but yeah.
Okay, let's see. You have function B that takes a B to a bool. Let's see.
Well, yeah, so suppose you have a function that takes a function from net to B's that takes as arguments an F which goes from a net to B.
No, we have F goes net to B, right? And now what do you want?
Now you have an operation on functions like that.
Yes,
that takes a function from net to B and returns something else.
Like this one here is good enough. The X.
Like the little b should be net to B. Is that
I see. You want here that's to B?
You want to say something like F dot G? No. I think that was Flores should talk. I'm not sure on it.
Yes.
Yeah.
We support this stuff here. I don't know if that's what you want.
Oh.
Wait, what is this?
You have F of 10 is a B. Now you can access the field. This equivalence is just a better.
It's another way of writing parentheses.
Yes.
Okay.
It's like a reverse $sign.
Yes.
Oh, so the reason, well, I guess you already mentioned this to some extent on Monday, but like, you know, as you know, we used old structure command a lot in MathLib. And the proposed alternative is to use an extends clause for the first one and a instance for the other, right?
Yes, that if you do that, you don't need to extend Lean4. Then you may say, oh, I don't feel like writing the instance by hand. Then my suggestion would be try to write try to write a command that giving A and B, if the fields of B, the leaves, right? You try to map all the fields of A to the fields of B and create this instance automatically for you. If they, based on the names of the fields, you try to do this mapping, right? Then you have to write, oh, add instance or something like that. I say, oh, this is still too much work. I want to write like in Lean 3 that you can have multiples extends and you merge everything. Then I would say, oh, then add a macro that instead of extends is joins A and C. You can say structure B that joins A and C, and it would map to extends A, and the other ones is the add instance macro, right? And then you have something that is superior to Lean 3, does everything that Lean 3 does, and is superior, because when you do the mapping, you're not mapping to atomic fields, but you try to find the common ancestors and to avoid the overheads that's the flat structure command produces, right?
Yep.
I would suggest only do that if it's really annoying the boilerplate, adding the extra instance by hand.
I think that for MathLib, we probably want to have something along those lines. Like, we'll probably need some kind of hierarchy builder style command, which will just organize all of the things that we generally need to do. Like, there's a couple things that we generally have to do in order to set these structures up so that they'll play nice with, you know, whatever the ambient Lean environment is. So I guess, you know, for something like this, I mean, we definitely have a lot of actual diamonds in, you know, MathLib structures. So, I mean, the boilerplate, like, we certainly want to avoid any boilerplate just because it makes it easier for people to get it right, you know. But I mean, as you say, like these are all MathLib commands that we'd be writing. I'm just trying to get a sense of like what they should look like.
Well, yeah, coming up, figuring out how the command should look like is a good first step, right? Everything, you can generate way more stuff than structure generates. If you know things should have a particular shape, right? You can try to automate that as much as possible. And potentially would save a lot of time, right? There was this talk, I think it was yesterday, when they have this tool, I forgot the name of the tool that generates outputs Agda or Lean codes or Coq codes, right? Yeah, trying to automate some of the things this tool is doing, it's feasible, right? Also limiting, preventing people from using features that you do not need is also helpful for.
So for the record, I just checked in Lean 3 and it doesn't work with the trick you do with XX. So I just pasted in the chat. So exactly, Sebastian. So what I pasted is the Lean 3 analog of what Leo had in Lean 4, and it doesn't work in Lean 3. And Mario claimed it worked in Lean 3, but it doesn't.
Wait, with an N to A?
Sure
No. I'm not saying anything about functions from N to A. That was what Flores was saying, right?
That's my example. Patrick has an example about it.
He says,
yeah, pretty sure.
Here.
I'm pretty sure it only worked for fields in Lean 3, right?
Yeah, this is what I claimed. Yeah, and
Yep.
then Mario
For sure, someone I can simplify.
Oh, I see. It's only for fields of the structure. Yeah. That's true. That's true. Yeah.
So it's great that it works in Lean 4.
Right. Okay. Yeah. Now I see.
Nice.
Yeah, that was a peculiar property of field. Like the only way that you can tell the difference between a structure field and other functions with the exact same type as a structure field is that they behave differently in this particular context. Yeah.
Are there more questions?
Yeah.
Have we exhausted ourselves? I'm feeling exhausted myself.
It was really nice. Thank you so much, Leo.
Yeah, you're welcome.
Thank you, Leo.
Yeah, sure.
It looks so exciting. It looks so beautiful. I hope that they will really make good progress with Lean 4 because people will be so happy to use this. I mean, the meta-programmers.
No, sure. It would be great. As I said, I'm happy to meet every week. I mean, for 1-2 hours and answer questions. I have been overwhelmed by the messages. I can't possibly answer in writing, right? The messages that people are posting on Lean 4 already. I mean, they're like 100. But I take a look. I may not answer, but I take a look. We can address verbally in the meetings, in face-to-face, because it's much faster, right? Some of the messages for me are like hints that we should improve some documentation, right? Like messages like how unification hints work, right? It's not worth answering there. It's better for us to write the documentation that we don't have, right? And put a link there to the documentation.
Yeah, sure.
Right?
And also probably all the examples that you wrote for this session, that they could go in the documentation if they are not there yet.
Yeah. That is. Yeah. It's a good idea. To add more examples there and
but since you
Sebastian,
prepared this, you should reinvest this work in there.
And sometimes it's hard to guess the level of detail that is useful, right? For the hardcore MathLib developers, probably introductory documentation is useless, right? It's much better to give examples showing how to do things, right?
I mean, I think we've learned with the MathLib documentation, there is no perfect level of documentation, right? Everybody wants
Possible, yeah.
So, you offer what you can offer.
Yes.
Right, but one thing to keep in mind is that this is something where the community can help. I mean, if you guys provide minimal documentation, we can all write tutorials and examples and things like that.
Yeah, this is all super useful. We write down readable documentation.
We're happy to have it.
Yeah.